Hello everyone, myself Kirtana J, pursuing my engineering in Sri Venkateshwara College of Engineering, Bangalore. Today, let us discuss about the deterministic finite automata. Let's look onto the topics: introduction, components of DFA, graphical representation of DFA, advantages and disadvantages of DFA, and conclusion. Let's move on to the deterministic finite automata. DFA recognizes whether an input string belongs to a formal language or what. It serves as a computational model for pattern recognition and language acceptance. For a given string, it confirms a specific language or word, making them a fundamental concepts in the theoretical computer science and automata theory. In DFA, the term symbol refers to individual characters or elements of an input alphabet. The input alphabet is a finite set of symbols that the DFA can process. The symbol is basically a basic building blocks of an input string which can read and analyze during the computation. Let us know what are the components of DFA. The components of DFA are also known as the five tuples of DFA that are state, start state, acceptance state, alphabet, and transition function. So, what is a state? A finite set of states representing the different conditions the automata can be in, which is represented as Q. Alphabet as finite set of input symbols that the automata can process, which is represented by sigma. Transition function, a function that specifies how the automata transition between the state based on the input symbol. It's often represented as a transition table or a transition diagram, which is represented by delta. Start state, the initial state where the automata begins the processing the input, which is represented by Q naught. Acceptance state, a set of states where the automata considers the input as a accepted state or the final state, which is represented as F. Now, let us know the graphical representation of DFA. DFA is usually represented using a state diagram. In the graphical representation, we make use of four states, that are states, transition, start state, and acceptance state. States are represented by circles or ovals. Transitions are represented by arrows between the states indicating the transition based on the input symbols. Start state usually indicated by an arrow pointing to the initial state. Accepted state is designated by a double circles, colors, or a label to distinguish them. Now let us look on to the small example which is recognizing the language of a strings with even number of zeros. The string which has a even number of zeros where we have a three states, that is a Q0, Q1 and Q2, where Q0 is a start state and Q2 is the accepted state or the final state. And the language is zeros, even number of zeros. So initially the Q0 will be the start state. So even number of zeros is translated from Q0 to Q2. Now let us look on the features of DFA. A key features of deterministic finite automata is their simplicity and efficiency in recognizing a regular language. Deterministic transition for each combination of the current state and an input symbol, there is preciously one next state. This deterministic nature simplifies the design and analysis of DFA. Finite set of state. DFAs operate with a finite set of state which makes them well-suited modeling system with a limited number of distinct conditions. Memoryless DFA do not have memory of a past input symbols. Their behavior is slowly determined by all current input symbols and the state. This simplicity makes them suitable for certain pattern recognition tasks. Acceptance criterion. Recognition of input strings is based on whether the DFA ends in an acceptance. The acceptance criteria simplifies the language recognition. Language recognition. DFAs are specifically designed to recognize a regular language, making them valuable in lexical analysis and pattern matching in areas such as compilers and text processing. Graphical representation. DFAs can be visually represented through a state diagrams, providing an initiative way to understand their behavior. Efficient implementation. DFS can be implemented efficiently both in terms of memory and processing time, making them practical for certain applications. These features collectively contribute to the usefulness and versatility of a DFS in various computational skills. Let us know what are the advantages of DFA. Firstly, the simplicity. DFAs are straightforward to understand and implement due to their deterministic nature and a finite set of states. Efficiency. They are efficient in terms of both memory usage and processing time, making them suitable for specific applications like lexical analysis in compilers. Clear acceptance criterion. The exception or the rejection of input strings is clearly defined based on whether the DFA ends in accepting state. Graphical representation. DFAs can be visually represented through a state diagram providing a visual aid for understanding their behavior. Regular language recognition. DFAs are designed for recognizing regular language, makes them well suitable tasks involving the pattern defined by a regular expressions. As we know the advantages, let us know what are the disadvantages of DFA. Limitedness, expressiveness. DFA can only recognize the regular language, limited their ability to handle more complex languages with nested structures. Memorylessness. The lack of memory can be a drawback for a task that requires remembering the past occurrence or a tracking nested structures. Deterministic nature. While deterministic simplifies the design, it can restrict the modeling of certain behavior compared to the non-deterministic model like NFS. State exploration. Complex patterns may require a large number of states, leading to a state exploration problems and making the DFA impractical for some applications. Not turning complete. DFAs are less powerful than turning machines and can solve problems that require attributory computations. As we know, deterministic finite automata is a computational model consisting of a finite set of state and an input alphabets transition between the state based on the input symbols, start state and the acceptance state. DFA has efficiency to recognize the regular languages and through their deterministic process of input symbols, making them a valuable for tasks like lexical analysis in the compilers, while DFAs have a limitation such as a lack of memory and inavailability to handle the complex languages. Their deterministic nature and clear acceptance criteria contribute to their practical use in the various computational applications. Hope it was informative and thank you.